In this lab, you will measure the salicylate concentration in forensic cases using UV-visible spectroscopy. The fluorescence UV-Vis spectrophotometer measures the absorbance and fluorescence spectra of various chemical and biochemical compounds. Acetosalic acid, or ASA, is commonly known as aspirin and is used as an analgesic to reduce pain, anti-inflammatory to reduce inflammation, antipyretic to reduce temperature, and platelet aggregation inhibitor to thin blood and stop clotting. It is one of the most frequently used therapeutic agents on the market, and due to this prevalence and availability over the counter, both intentional and accidental poisonings are fairly common. Therapeutic blood levels of salicylate, the measured metabolite of ASA, range between 20 to 200 mg per liter, toxic levels are greater than 300 mg per liter, and fatal levels are possible over 400 mg per liter. Vernier has combined the functionality of a fluorometer with the power of a UV-Vis spectrophotometer to allow users to easily and accurately conduct numerous fluorescence experiments with compounds such as quinine sulfate, DAPI, GFP, and tryptophan. Exchangeable LEDs ensure you get the exact excitation wavelength needed for your experiment. The cord attachments include the power cord and a USB cord that allows for data collection using the software, Logger Pro 3. Once all cords have been attached, the software can be opened on the computer. Here, the instrument will register as connected in the top left corner and a blank graph will appear. Quartz cuvettes are used to record the absorbance in each of the samples. For this lab, we will need to first calibrate the instrument using deionized water as the calibration solution. First, rinse the cuvette with water to ensure cleanliness, then pipette approximately 3 ml of deionized water into the cuvette for measuring. Before inserting, make sure to wipe the outside of the cuvette with a Kim wipe to ensure there is no residual solution or other markings that could interfere with light transmission. Place the blank cuvette in the right-hand slot of the spectrophotometer. Align the cuvette so the clear sides of the cuvette are facing the light source and the arrow. In the software, choose Experiment, Calibrate, Spectrophotometer 1. As a note, do not overfill the cuvette as it will splash into the instrument. Any excess liquid can be poured into the chemical waste beaker. Follow the dialog box instructions, click Finish Calibration, and then click OK. Pour your blank solution from the cuvette into the 250 ml chem waste beaker. Rinse the cuvette once using DI and pour the rinse aid into the 250 ml chem waste beaker. Rinse the cuvette a second time and pour the rinse aid into the sink. After calibration is complete, you can begin taking measurements of your standards. For this purpose, we will mix 3 ml of each of our salicylate solutions, standards and unknowns, with 12 ml of a 5% solution of iron 3 chloride. This will create a complex of ferric and salicylate ions, which appears red-violet and results in absorbance within the range that we can measure, around 530 nanometers. To begin making the standard solutions, we will need to perform a series of dilutions. Starting with a 200 mg per liter salicylic acid solution, we made standard concentrations of 200, 150, 150, and 0 mg per liter, as seen in the amber glass bottles. Ensuring that it has been rinsed since standard preparation, use the 25 ml graduated cylinder to measure 3 ml of each standard solution with 12 ml of 5% iron 3 chloride into each beaker. Rinse the graduated cylinder once with DI. Pour the rinse aid into the 250 ml chem waste beaker. Rinse the graduated cylinder a second time with DI, this time pouring the rinse aid down the sink. Repeat these steps for each standard sample. Fill the cuvette with the next sample to be tested, which would be your 0 mg per liter salicylic acid sample. Wipe the cuvette with a Kim wipe and place the cuvette into the spectrophotometer, ensuring the correct orientation. Select Collect from the toolbar. The data will be generated almost immediately. Once the absorbance line appears smooth, select Stop to end data collection. Save your data by selecting Ctrl-L. Rename your data by selecting Data, Data Browser, and double-clicking on your data to rename it with the appropriate sample name. Pour your solution into the 250 ml chem waste beaker. Rinse the cuvette once using DI and pour the rinse aid into the 250 ml chem waste beaker. Rinse the cuvette a second time and pour the rinse-aid into the sink. Repeat these steps for the remaining 4 standards of 50, 100, 150, and 200 milligrams per liter.